What we'll really get into now is kind of the essence of programming, where we move from executing a sequence of commands, some addition, perhaps executing a function of sort, into dynamically reacting to certain conditions in our program, and with that executing different branches of the code. So we really move from linear execution, which you could perhaps understand as some kind of batch programming, to a more complex tree. And this is achieved with very few basic tools, as you'll see. So we're redirecting the stream. We're going from one branch to another branch. Flow control turns batch processing into programming. So again, moving from doing A, B, C, D into doing A and B, and then C if one condition is met, or D if it is not met, right? High-level programming languages allow different behavior based on conditions you define. Conditions can either be true or false. There's nothing in between, right? We want certainty in what we're doing here. You want to be sure to say, I either want to go that route or that route. No, maybe is not allowed. There are various ways we can test conditions. We can use equality operator, less than or equal, greater than or equal, not equal, etc. These symbols differ in the respective programming languages. We'll get into the actual symbols a little bit later for Python and the shell. Some built-in functions also implement tests of conditions. For instance, in Python, the NumPy package comes with a function that allows you to test whether or not a number is finite, and it gives you a true or false depending on whether or not A is finite or not. And now you will hopefully see the importance or the use of the logic tables that we talked about last lecture and that you got to deal with in the homework. So on a very high level abstract view, this is what flow control can look like. You come in, right? This is our flow chart. You come in, there's a condition that can be true, and then you branch into doing something, and then perhaps you go back. And hopefully, at some point, this condition is going to be false, because otherwise you're stuck in an infinite loop right over here, right? So it's something important to keep in mind. If that condition is false, we might end up over here where we're in a loop and do something, a certain number of times. X times is said here, so there's some kind of counter that keeps track of how many times we've been doing this, and then we move down here. So these things have different names. A condition is an if statement. If A, then B, otherwise do C. The condition and something that we're doing in a loop is what we call a condition loop. It's often also called a while loop. So, the concept of an if statement is kind of built in to the framing of that loop. And then there is a count loop where we want to do something a number of times. I hope that even now it is quite intuitive that if you need to do something 5 times, it's not a good approach to just write the commands out in the code 5 times. You need to make sure that the change in the code is propagated to all of the lines where it occurs. A for loop or a count loop allows you to write the actual code once, right? Everything's compact. We understand a lot better how often something is happening, and we change it once, and then it's executed for what's changed for all of the executions that are going to happen. Something that I find useful is formal language definitions that you might come across in documentation of programming languages, and we'll delve into that here a little bit. Basically, I give abbreviated version of this. We can have a block, for instance, and that block can be composed of a list of statements that is oftentimes enclosed in some curly braces in some programming languages. Python actually requires you to format things a little bit differently. Go into that when it comes to that. A statement list is defined as a single statement or a pre-existing statement list with another statement added on. Okay, doesn't help very much. Now we go to the bottom of things here. What is a statement? Statement can be a block, so a list of statements. It can be an assignment. Okay, so now we're kind of terminating things, right? Can be an assignment, so you can have a variable that gets the value 5, right? That is an assignment statement. We've seen that in previous lectures. It can be an if statement, a for loop, a while loop. Some programming languages also have a do statement. We're not going to get into that very much, or some other things. It's important to kind of see that this is basically defining the grammar of a programming language. So for each programming language, this looks a little bit differently. But within these fairly formal, generalized frameworks, we can then move through and define what an if statement in general looks like, what it looks like in Python, what it looks like in the shell. And I integrate this here so you are prepared to easily pick up other programming languages if that is something that you're interested in your future career.